The Martian vista may have a feature we never guessed before: patches of sand floating in the air. The terrain on Mars has always fascinated scientists and, in particular, features that have hinted Mars might have water. That big mystery was solved in 2005 when NASA confirmed that water still flows on Mars' surface today. And that obsession with surface features has led to an intriguing proposal that small pockets of boiling water levitate patches of Martian dirt. That proposal is described in a new article published in the journal Nature Communications. Working in a lab, the team behind it tried to recreate the phenomenon in a chamber designed to mimic conditions on Mars: low air pressure, a dune of thin sand on a tilted ledge, and temperatures set to 40 or 73 degrees. Keep up with this story and more by subscribing. Know if 73 degrees isn't very hot, remember that Mars has almost no atmosphere, hence that very low air pressure. This means it's exceptionally easy for liquids to become gases, so water boils at just 50 degrees. Then, the team added water and what happened? They found that, in the cold simulations, most of the sand moved because of water flowing over it. But in the warm simulations, that overflow caused only a small fraction of sand movement. Here, much more of the sand was moved by more exotic processes: ballistic ejection, levitation, and dry avalanches. Gullies along the edge of Krupak crater on Mars. The planet's surface has never ceased to fascinate scientists, who are proposing that small pockets of boiling water levitate patches of Martian dirt. NASA's Ulka Dekunev of Arizona: "We saw in our experiments that wet sand pellets were somewhat floating over the sediment," lead author Jan Rock, a planetary scientist at the Open University in the UK, told New Scientist. They found that their experiments levitated pellets of sand up to 2 inches across, and estimate that on Mars, those pellets could be flung as far as 6 feet. That makes for much more surface-shaping action than small dribbles of water themselves. But the team's theory will be hard to verify on the red planet itself. They don't think any pellets will ever grow large enough to be spotted in the images we receive from spacecraft orbiting the planet. And while NASA has 2 active rovers exploring Mars, Opportunity and Curiosity, both have strict orders to stay away from any areas of the surface that scientists think have water. While that's like a measure that would hamstring science, it's actually crucially important. Before they left Earth, neither of these robots was sterilized to the extreme degree necessary that astrobiologists are comfortable allowing them to visit our best bets for finding life, for fear they might contaminate the site. And besides, then they'd have to dodge clumps of flying sediment. As if being a rover 140 million miles away from home isn't tough enough already.